Okay, let's take a look at our second example. We are going to first look at the green line, okay? So let's first think to ourselves, okay, let's see on the graph what it is when x is 0. And if I go to 0 on the x-axis, if I'm looking at the green line, the y is also 0. Let's look and see what y is on the graph when x is 1. So I'm going to go to 1 on the x-axis and then go up to 2. And that's where it crosses the y-axis. So I'm going to say when x is 1, y is 2, according to the graph. Okay, so let's keep moving on. Let's see what y is when x is 2. Okay, so go to 2 on the x-axis and see where it crosses the line. Well, here it intersects with the line. And right here we see that when x is 2, what is y? It's 4. And let's do one more. Let's say 3. Okay, so let's go to 3 on the x-axis and go up and figure out where it meets the green line. And it meets the green line right here. And so when x is 3, y is 6. Okay, now what do we know about our patterns? We have two different kinds. It can either be additive or multiplicative. Well, this line goes through the origin. Which did we say? Which pattern did we say always goes through the origin? Do you remember? Our multiplicative patterns always go through the origin, don't they? Because every time we multiply a number by 0, we're going to get 0. So let's see. Do we see a pattern? One of the things we can also check and see is if the additive pattern characteristic fits. And in this case, remember, one of the characteristics are when you increase x by 1, the exact same thing happens to y. But here when we increase x by 1, we go up to 1, 2, 3, our y increases by more than that. It goes 2, 4, 6. It's increasing by 2 each time, isn't it? So that's another reason why it's multiplicative, because it doesn't follow the additive rule of increasing by 1. Okay, so let's think of this as an input-output table. What is happening to x to give us y? What do you notice? So we know it's multiplicative, so we know we're going to be multiplying something. So what are we multiplying by x to get y? Well, have you figured it out yet? We're multiplying everything by 2 to get y, right? So if we said x is 1, 2 times 1 equals 2. Check. Oops. Let's say x is 2. 2 times 2 equals 4. Check. 2 times 3 equals 6. Check. So every time we multiply x by 2, we get y. So our rule must be 2x equals y. Let's...
Please pardon this interruption.
Sorry, I had a little announcement. An announcement interruption there. Okay, so now let's look at our blue line, because we have decided that this pattern must be multiplicative. And honestly, that's all you have to know. You don't have to know the rule, but it really does help, doesn't it? Knowing the rule helps you understand what kind of pattern you're dealing with. Okay, let's take a look at the blue line. And let's start with 0. So we're going to go along the x-axis to 0, and we're going to see where we intersect the blue line. So we meet the blue line right here at 6. So when x is 0, y must be 6. And let's see where we intersect the blue line when x is 1. So we're going to go along the x-axis and find 1, and then move up to see where the blue line crosses. So it crosses right here, and it looks like it's right at 7. So when x is 1, y is 7. Let's keep going. And let's try something else. Let's not go up by 1. Let's go up by 2. So let's see what happens when x is 3. So I find the 3 on the x-axis and go up. And we see that we meet the blue line at the 9. So when x is 3, y is 9. And let's go up 2 more. Let's say, what is y when x is 5? Go up. And we see that we we meet the blue line when y is 11. So we can say that when x is 5, y is 11. Okay, so let's look at our table and our graph. What characteristics does it have? Does it have the characteristics of an additive pattern or a multiplicative pattern? Well, here, when x is 0, y is 6. And we know that multiplicative patterns have 0, 0 as an ordered pair. But this does not have 0, 0 as an ordered pair. It has 0, 6. We also know that whatever we increase x by in an additive pattern, the y would increase by the same amount. So here we increase x by 1, and the same thing happens to y. Or we increase x by 2 each time, and the same thing happens to y. So let's look at the pattern across between x and y. What are we doing to x to get y? Are we multiplying something? Here, if I multiplied 1 by 7, I would get 7. But if I multiplied 3 times 7, I wouldn't get 9. And remember, it has to be the same number for all the x values. Just like here, we multiplied every x by 2 and got what we got for y. And so I'm not thinking it's a multiplicative pattern. So what's the other pattern it could be? Additive, right? So let's think, what could we be adding to x to get y? So something plus x equals y. And if you remember, Ms. Wagner said to always look at the 0. That's like the big giveaway, right? What could I add to 0 to get 6? Well, the only thing I could get, 6 plus 0 equals 6. Let's see if the rest of our x values follow along. Let's say x is 1. 6 plus 1 equals 7, and that's what our table says. Let's plug in 3. 6 plus 3 equals, well, 6 plus 3 is 9. And awesome, that's what our table says. And then let's do 5. 6 plus 5 equals 11, just like our table says. So it looks like our rule for this line is 6 plus x equals y, which is definitely an additive pattern, isn't it? Because we're adding. All right, so in your homework, I've given you a line and part of a table. So what I want you to do is fill out the rest of the table by looking at where the line crosses the y-axis, okay? And also think, okay, if x is 3, what is y? Okay, and then fill out your y values. Thank you, Ms. Young. And then you're going to circle. You're going to decide, is this showing an additive pattern or a multiplicative pattern? And I want you to circle which one you think it is. Then you're going to type in and tell me, why did you pick that pattern? What about the graph or what about the table shows that you think that pattern is additive or multiplicative? Okay? You have 4 problems to do, and then that is it.